Okay, this is Giancoli Physics, 7th edition, AP edition. We're in chapter 10, fluids, working on problem 9. Let's go ahead and dive in. The question reads, estimate the pressure exerted on a floor by A, one pointed heel of area 0.45 square centimeters, and B, one wide heel of area 16 square centimeters, as shown in the figure below. The person wearing shoes has a mass of 56 kilograms. The mass of the shoe we're going to ignore, assuming the mass of the person is noticeably greater. So go ahead and take a moment to wrap your brain around this problem and see how you attack it. So this is a level 1 problem. It uses the definition of pressure. On your equation sheet or in your textbook, it should show you the mathematical definition of pressure, which is force per unit area. Notice here we got areas that we're doing for both parts A and B. They're asking you for the pressure. And all we need is the force. From previous study, you should know that you can calculate the force exerted based on the mass of the person standing in the shoe using the acceleration due to gravity to calculate the force of gravity. We'll make that substitution as we go. So the pressure is going to be the force of gravity, which we'll replace with mg, divided by the area, which is just a given number for this problem. So fairly plug and chug at this point, although we're likely going to have some unit conversions. We'll take a look at that in a second. For part A, mass of the person 56 kilograms. Acceleration due to gravity, what it's always been. Divide by the area. For part A, that area is the spike heel of 0.45 square centimeters. Now the kilogram meter per second squared gives us a Newton. We have square centimeters in the denominator. Now they didn't specify what pressure they want. And as long as you have a force per unit area, it's acceptable. However, if you'd like to put this in pascals, which is a a Newton per square meter, it wouldn't hurt here to convert those square centimeters. And as always, we're going to multiply by the number 1. My centimeters are in the denominator, so we'll put them over here in the numerator. I would like meters so I can get to my pascals. There are 100 centimeters per meter. This is our number 1, but these are squared, so I need to square my number 1. And that should give us our final answer in newtons per square meter, which is pascals. Now go ahead and pick up your calculator and see what number you get. It's never a bad idea to do some mental math with these sorts of problems. In this case, I've got a 56 divided by a 0.45. Those numbers are roughly equivalent with the exception of the 2 decimal places. So move the decimal over. So it'll give you 10, correction 100 between those two. Times the 10 here gives you 1,000. And then we multiply this by this 100 squared over here. 100 squared is 10,000. So this 10,000 combined with this roughly 1,000 is going to give you about 10,000 thousands, which is 10 million. So we expect a very large number here. So go ahead and try your calculator to see what you get. Okay, so your calculator should have spit out a number. About 12 million. You get 12,196,000 approximately. Given that atmospheric pressure is about 10 to the 5th, or right around here, that's a significant pressure. With our significant figures in our problem being 2, we'll round it to something more appropriate and put it in times 10 notation. That's 367. 1.2 times 10 to the 7th pascals. Now for part B, it's the exact same question, but just a different area. So we're going to rewrite this problem. Exact same equation. Another reason to do all of your algebra first. You don't have to redo this problem now. You just use the same result, plugging in the new numbers. You still have a 56 kilogram mass. We're still on planet Earth as far as we know. And now we're going to divide by the area of the new shoe, which is 16 square centimeters. We should expect a significantly lower pressure here. This is the same principle behind the bed of nails. One nail would certainly impale a person laying on it, but a bed of them can create lots more area in this equation, significantly reducing the pressure. Again, we would like to convert this into pascals, just so we're comparing common units. Now, these are the same numbers we had in the previous problem. If this was 0.5, 10 of those would be 5, then 3 of those would be about 15. So this number here is about 30 times bigger than this number. So we would expect our final answer here to be about 30 times lower. Again, with a 3, that would make that about a 0.4. Move the decimal, 0.04. So we're looking at 4 times 10 to the 5th-ish is what we expect. So go ahead and pick up your calculator and see what you get. And your calculator should spit out a number, 3.43 times 10 to the 5th. So that is in the realm of what we expected. That answer is reasonable. And it is, in fact, significantly lower than the spike field. That takes care of this problem. We're on to the next.